Good morning. I'm George Turner. I actually work for Indiana University. I'm their chief systems architect for research systems. I've been doing scientific computing for about 40 years. So if you have questions on just about anything, please feel free to speak up. As Amy said, as I'm going through the slides, and this will actually become a live demo where I'm typing in a terminal window, and hopefully you're following along and trying the same commands as I am. And if you have questions, please speak up. If you have a question, somebody else probably has the same question. And it's best to actually fill in this information right now so that when we get a little farther along and we're building on the information, you're just not adding confusion upon layer of confusion. So we have a pretty small attendance here, 17 people. So again, this is just more of an opportunity for this to be an interactive session than just a lecture or workshop, something like that, where I just stand here and just talk on and on. So again, hopefully this is interactive. You're in the process of getting logged in. If you have any problems, please speak up in the chat, and somebody will be there to help you. Now, for my hardest part, let's see if I can actually get the sharing to work. For any questions, if you want to get in touch with me, or if you have questions about the system, anything, this is the first stop shop for getting in contact with the ARC team. This is an introductory tutorial. If you're interested in something more advanced, please start the conversation again by contacting ARC Info. This tutorial is focused on Linux in a research computing environment. And essentially, that means just using the command line from a terminal. We won't really get into Linux on like a desktop or a laptop, but hopefully a lot of what you learn here would carry over. To log in to the ARC, as Amy said, you must be on the UC campus or using the VPN. People are standing by to help. And while you're logging in, we will go over some basic terms, histories, things such as that. Again, this is probably a repeat of the information that Amy posted, but you would log in using SSH to your username at arc.uc.edu, where username is either your UC 6+2 or an otherwise a username that you would have been emailed earlier. If you have problems getting into the system name arc.uc.edu, you can try the IP address 10.127.5.254. First and foremost, this is a live presentation, and the goal is to show how you use a terminal window and the Linux command line interpreter. The slides for this tutorial are less important than actually trying the commands as we're moving along. At some point, I'm sure this will degenerate into something little more than a stream of conscious, where I'm babbling on, typing things in. And if at any point you don't understand what I said or why we're doing something, please ask questions. I cannot emphasize this enough. And especially, why are you doing this? If you have that question, please speak up. And as an old astronomy professor once told me, whenever you're starting a live demo, never preface it with anything more predictive than watch this. With that, man pages are your friend. So on a Linux or a Unix system, I will be using the terms Unix and Linux interchangeably here. I have a slide on that in a little bit, but the help command on Linux is man, and man is just short for manual. You'll see that a lot of these commands that we touch on today are abbreviations or shortenings, or perhaps just the consonants with no vowels, something like that. So man stands for manual, and man space command will give you more information than you probably ever want to sort through. There's also a man-K for keyword. So like if you want to find a command related to copy, you could do man space -K space copy, hit return, and it will return all kinds of commands related to copying. Google, the Google machine is your friend as well. I would suggest after we get out of this tutorial that you go to either YouTube or the Google machine and type Linux tutorials. You're going to find a lot out there. I don't think we'll get to Slurm, but that's another topic. At the very end, I have some slides on Slurm. If you get to the point where you feel comfortable using the command line on the clusters, then Slurm is probably the next place you want to start looking. Linux versus Unix. As I stated earlier, I will be using these terms interchangeably. Linux is open source and was developed by the Linux community starting in the 80s sometime. Unix was developed by AT&T Bell Labs in the late 60s and 70s, and it is not open source, and it is copyrighted. So the programs are identical. Well, to first order, the program you would execute on Unix would be identical to Linux. However, the source code on Linux was developed from scratch. If you've ever looked at Unix code, they don't want you writing Linux code because of the copyright issues. SSH, hopefully you know what SSH is. You're already using it and have logged into the cluster. It's a means of communicating from your desktop server or your laptop to connect to the clusters. Again, I'm sort of going to keep emphasizing over and over that the research clusters are command line tools. I hopefully will have some time to touch on the some GUI applications we have for manipulating the clusters. But by and large, these HPC clusters are command line driven. If you see a pound sign or a hashtag, depending upon what you, how old you are, in Linux, that's a comment. So anything after that hashtag would not be interpreted by the command line interpreter. I may talk about stdin, out, and error. This is your standard input, your standard output, and your standard error. So this is standard input is input coming from your keyboard. I will show you how to pipe input from a file into a running program. Output would be normally what goes to your terminal screen. I'll show you how to use pipes to pipe it to a file or perhaps into another running program. And stderr is very much like standard out, but it can't be redirected as you would standard output. That way, if you're piping the standard output to a file or to another running program and an error message gets written to standard error, it will still show up on your terminal. There are ways to pipe that out, and I'll show that as well. Directories is a term that I will be using over and over again. They're identical to folders on a Mac or a Windows machine. So if you hear me say directories, that's the equivalent to a folder. It's essentially a place to put file. You can have directories within directories, and you create a hierarchy. It's actually a hierarchical file system. So that's another term that you may hear quite a bit in the Linux environment. Man, I've already talked about man and man-k. PWD is present working directory. So if you'll see a couple commands down, I have cd, which is change directory. So when you cd into a directory, you change directory, and then a new directory becomes the present working directory. A lot of times you use these directories to organize your work hierarchically, and it's a concept you need to be very comfortable with. CP is a command. Actually, if you do this cp-rp/op/opc/ oops, that's wrong. Do not use the top command, but actually there on the second line, you'll see opt HPC training FDW for faculty development workshop -L101, Linux 101, and to date. So if you copy that file, space period, then that will copy this directory into your current working directory. And later on, we will do some things in that directory with files located there. You will see me use the commands cat, more, and less. A lot of times this is just a way of seeing what's inside a file. I'll have text files, and I might just say cat, and it'll copy it to standard out, which is the terminal screen, or I might pipe it into something else. More is a way to look at a file, the text in a file, one page at a time, and less is very much like more, except that you can move up and down, whereas in more, you can just advance one page at a time, and when you get to the bottom, it quits. So less is a more way to do more. Anyways, modules are important. I'll talk about modules here in just a second. In a Linux environment, and especially on the HPC cluster, you can change your environment. I'll describe environment here in a little bit also. So there are various, the ARC team has installed software, and you can use modules to bring these programs into your environment or to get rid of them. So if, say, just as an example, you want to use MATLAB, there's a way with the module load MATLAB command, you can make MATLAB bring that into your environment. And echo is a command that I'll be using quite a bit. And echo just repeats. It's like a print command, and it just repeats whatever is coming into standard in to standard output. So hopefully by the end of this tutorial, you'll understand these dozen or so basic commands that I'm going to be using over and over through this presentation. Some other important things, I mentioned the environment variables. These are essentially the state of the shell. The shell is the command line interpreter, and there's various different shells that you can have in a Linux environment. Today we're using the bash more than likely. If you know how to change your shell, then this tutorial is probably a little bit too basic for you. It started off with SH, or just shell. Then bash is the born again shell. ZSH, I don't know what that stands for, but it's essentially another version of the bash. Corn shell is very similar to bash. C programmers tend to like the TCSH because its syntax is very much related to the Kernel and Ritchie C language. And there's many other shells out there. A process is a running program. So we'll actually, some of the commands we will be executing later on, we will be looking at processes, we will create processes, and hopefully you have a good understanding of that by the time we get to the end of this tutorial. Understanding what a process is pretty important. As far as processes, you have parent processes and child processes. And each process has a process ID. The very first process that starts when you turn on a Linux computer is called the init process, and it is process 0. And every process created after that increments by 1. And we'll get into this in a little bit later. But anyways, back to the parent and child processes. We will actually, right now, we have two processes. We have a parent of our current child process, and I'll show you what that is. When you start running a program, that program or application that you're running becomes a child of your current process, and you are then the parent of that child. So again, you see this hierarchy building up. Oh, editors. Unix and Linux was developed. Everything is a file on a Unix system. So putting text into files is a very important, and manipulating the text in a file. So I'm going to briefly touch on some editors. We do have Nano installed on the ARC, I believe. It's a very easy to use in the sense that at the bottom of the screen there is a menu so that you can remember how to insert text or delete text or get out of the program. But Nano is not on every Linux system. The next editor is VI, which will always be on a Unix or Linux systems. Sometimes it's called VIM, but there's always a synonym VI for VIM. There's cheat sheets available at that link on that I have there. Actually, that devhints.io. If you're ever looking for a cheat sheet for something related to Unix and Linux, that's a good place to go. This gentleman, Rico, I don't remember his last name. He's created a lot of these cheat sheets, which I find invaluable. If you're in the VI editor, there's a difference between insert mode and not insert mode. So you have to type I to get into insert mode. So if you want to insert some text, you have to go into I, and then to get out of insert mode, you hit the escape key. To save your work, you do escape WQ for write, quit. And if you want to get out of the editor without saving any changes you've made, then you do escape Q, exclamation point, for quit, exclamation. Emacs, again, if you know what Emacs is and how to use Emacs, this tutorial is too basic for your needs. Emacs is very powerful. It's written in Lisp, so you can use the Lisp programming language to extend the capabilities of the Emacs. Once you start down the path of using Emacs, you'll never go back to something as so simple as VI. But I've never gone. I just find it too complicated. I got work to get done, and I just stick with VI and do it. There are graphical GUI editors. Gedit and Nedit are two of these popular ones. Gedit is almost on all Linux systems. Nedit may or may not be. I've just been using Nedit since the mid-'80s. The coolest thing about Nedit is that I can cut and paste columns of data, and I find that to be very helpful. And I would be remiss to not mention the sed editor. I might actually use a sed command here once or twice today, but I've tried to give you an example where I cat a file. So whatever's in file is just some ASCII text, and I'm changing the word this to that, and I'm piping it out to an output file. But sed, once you learn how to do this type of piping, sed will become a rather very powerful tool for you. I'm not going to say too much here. I will demo this once I get logged in and I'm typing commands into the terminal. Module, as I explained, is how we change the shell environments where you can bring in, say, MATLAB or ANSYS or various different compilers. If you want an old GC6 version of the compiler or something newer, you can change whatever version of the compilers you want. Bottom one there is module list. This shows you what modules you have loaded. So here I did get the copy instruction correct. So if you want to copy that directory over to your current working directory, notice there is a space between the 210114 and that period. That means copy recursively everything in the first parameter to the second parameter. And the second parameter is dot, which is current working directory. A little bit more on that. I mentioned the CD command. Once you copy that over, you will have a new directory where you are. And if you CD into that, then that directory has become your current working directory. And then this ls for list will list the files in that directory. I'm going to briefly blow through a bunch of these slides, and these are more for use later on at your own pace. This is an example on how to compile a very simple command, a very simple C program. It doesn't look like it does anything, but it does everything a real program does except work. And I mean work as in the physics sense of that word. The program has to load into memory. You load what's called a pre-program counter. You execute Go, and the program runs to completion, and then it runs an exit and shutdown process. So it does everything that the any program does, except it doesn't really produce any effect in the universe. This is Hello World. The first program in every programming is a Hello World. So here's a hello.c. You will hear people talk about the kernel. Where I mentioned, if you remember back earlier, I mentioned the process 0, the inet process. That's essentially the kernel starting up. Well, the kernel is what runs all the other programs. It also controls the hardware. There are things called drivers, which allow your programs to interact with hardware through drivers. The command syntax, we've already had some examples of commands like ls-al. So you have the command as the very first parameter, ls in this case, and you can have multiple parameters, -al in this example. I did mention process. Actually, I think, I'm going to jump over to the terminal because it's at this point, it's best that I actually start doing these commands rather than sitting here and babbling about them. Environment, this is very important, so sort of pay attention to when I get to that. There's 2 different types of quotes. A back quote is even a third thing that's totally different. File systems, I'll talk briefly about that. Pipes are important. We'll talk about that. We have some, I've mentioned cat, echo. Most of these I've already done. A couple in case I forget it and lose my train of consciousness. Close to the bottom, you will see DOS to Unix and Unix to DOS. If you are a Windows user, if you create a text file on your Windows machine and you copy it over to the cluster, you will need to do this DOS to Unix command. And reverse, if you create a text file on the Unix system and you copy it back to your Windows, you will need to run this Unix to DOS command before you do the copy. What's happening here is that if you have a file and at the end of that file is the line terminator, as it's called. Well, the Unix environment uses a different line terminator than a Windows box. So what you're doing is you're just changing those two, or interchanging those 2 different characters. I don't know if I'll get to tar and zip. If you're a Windows user, you probably use zip to pack up files. Tar is essentially the same concept on a Linux system. And a way to compress files and uncompress them is the gzip and gunzip. You can always do the man space gzip again to get the more information than you ever want to know. I've thrown in some other information at the end of this presentation in case I run out of material. I usually don't. But containers are very popular. If you're a researcher and somebody has told you, I have a Docker container I want to give you so that you can run my program, we are set up on the ARC clusters to do this work. We are not set up to create containers. We are set up to run containers. So if you have a need for that, contact the ARC info, set up a time for consultations, and we can get you going with that. Here's a brief list of some tutorials and other references. We are using, well, the very first one is just a basic Linux introduction, more or less what we're doing today, but I'm sure they're going to cover different topics than I do. The Beginner's Guide to Bash Terminal. We're using this bash shell, so this is a good thing to learn. The cheat sheet I mentioned before, this is a good place to go. And I specifically listed the bash cheat sheet. You will find this invaluable. An introduction to high performance systems at ADACS. This is more about how to use the terminal and command line interpreter in an HPC system. It's a little bit more advanced than what we're talking about today, but you might find that helpful. And then Tutorials Point is, again, another place that has many, many, many tutorials on many things Unix and Linux related. And specifically, again, I point out the Bash one. You'll find that useful. Just another reference to Singularity and Docker. And I believe from here on out, this is just, here's a history of the ARC clusters and what we have here. Just a history of them. If you read this over and have questions, Slurm is the way we could control and manage the cluster. So a resource manager essentially just takes an inventory of what resources are out there, what jobs people want to use, and matches them up using a scheduler. If you get to the point where you're pretty good at these commands, I have a couple of pages of Slurm commands that you'll want to learn, and these will become your everyday left-handed screwdrivers. So with that, I'm going to try switching from PowerPoint. Okay. I assume there's no questions, so I'm going to plow forward. So I've logged in here, just as a little history. Here's where I SSH'd into the ARC cluster. Since I'm coming from my home computer, my name is different than Turner GG. I have to actually put it at the beginning here. So usually if my username on my laptop was the same as it is on the UC campus, then I would just need to do SSH and then the name of the host. So anyways, so I had to enter, I didn't use a password. I used PKI infrastructure. This is public key infrastructure. This is a way of, I have a private key, which is equivalent to a password on my computer. I have a public key on the UC cluster. And so to enable my private key, I need to type in a password. There's a handshake that takes place, and I'm able to log into the ARC cluster. This next line, if you're going to use those GUI editors or X windows, like from MATLAB or something, this may or may not be an issue. Essentially, this is just dealing with forwarding windows back from the cluster to my laptop. This is sort of important to pay attention to just from a security standpoint. Being a sysadmin, I'm very paranoid about my systems. So now if this had said that I had logged in from, my last login was from, say, Brazil, I should be very concerned because there's no reason for me to have logged in from Brazil. UC at Blue Ash, yep, that's probably someplace I would have come in from. This is a welcome message. So at this point, you actually have a process running on the ARC login node, and modules are being restored. So I've been using this term process. So let's take a look at some processes. I'm going to use the PS command here. So these are processes that I control. So if you see here, I have the process ID, which is what I mentioned earlier. That's the bash shell. And when I type the PS command, that's a child process of this parent process. I'm going to use the -EF parameters. This will show me every process on the cluster. That's way too much. Actually, okay. This vertical bar here, this is a pipe. So I'm going to pipe information from this command into the next command. So what's coming out of standard output from this command is going to go into the standard input of this command. And grep essentially means search. Give me only the give me only the strings that have PTS/4. And I chose that because up here, this TTY, that's the terminal. So when I logged in via SSH, the Linux system created a terminal for me, which is PTS4. So I just want to see all those processes that are attached to PTS4. Actually, let me do another one. Head -1. So I want just the header, the head, the first line of the output. For extra credit, I'll let you guess what you get when you do tail. So anyways, imagine that this line is above here. So you see the UID, that's my user ID, that's my UC 6+2. Also notice that we have this user who's, they have the terminal 40, whereas I have 4. So that's why we got their output included with mine. We have the process ID. So we see up here the PS command was this number here. If I look down here, well, actually the number will have changed because it's a new process. But the next command or column is the parent process ID. So, and then that number is the same as this number up here. That's my bash shell. So every command I execute from this bash shell will create another child process, and it will have an ever incrementing process ID, but the parent ID will always be the bash shell. Now I could have a child of a child, and you'll have this hierarchy building up, so on. So, skipping the C column, this column here was what time did the command start, what was the the terminal attached to it, how much time has this process elapsed, and what is the command being run, okay? So, another very useful command, ps-ef, WC is word count. So I'm going to look at every process on the system, and I'm going to count up how many there are. So essentially, this first line here is how many lines there are. The second word is how many words. So each one of these entities separated by a space up here above is a word. So there's 872 processes running right now. And this is how many words, and this is how many characters that it output. So if you just want to do a PS-EF and hit return, you can sort of get an idea for what's going on the cluster. Another way to look at processes is the top command. So hopefully you can see this, and about every second or so it's going to be updating. I'm going to start in the lower portion of the window here, down in this section first. And so again, we have this process ID, the username, priority. The lower the priority, the higher, the faster it will. The lower the priority, the higher the dispatch priority you have. So if you have something with a priority of 20 and something with a priority of 15, the 15 will run before the 20. The next line is the nice indication. There's a way of saying I want to run a program, but I want other people. I don't want to interfere with other people. You can add a nice to your priority, and that will actually lower your priority, so actually make the number higher, so that other people can run. These next three, the virtual, the resident, and shared. Excuse me. This is how much memory you're using. Okay. S is not necessarily important. CPU is, though. When you're running a program, you want to, this is how much of a CPU you're using. And I'll get into this in a little bit. This percent memory that's related to these three columns we had talked about earlier. This is how much of the memory you're running. If we look up here above, we have a line where kilobytes of memory. So this is how much memory is available total on this system. This is how much has not been used. The used is how much is being used. And there are buffers and caches, which is a way of speeding up performance. Not until you're doing I/O and moving data between processes will these become available. Usually, I will briefly talk about swap memory. So this Linux is a virtual memory machine. Now we only have 196, this is actually gigabytes if you count up all the zeros, right? There's 196 gigabytes of memory on this server that we're logged into. But there are certain programs, this idea of virtual memory comes about in the 70s and really gets into use in the 80s, where I only have a certain amount of memory, but I need more memory for like whatever model I'm calculating is bigger than the amount of RAM I have. So you can create a file so that you can swap pages in and out from this file. So I have let's just using round numbers, let's say I have a program that needs 150 gigabytes of RAM, but I only have 100 gigabytes. So that 50 gigabytes can actually reside on a file. And if I need a piece of memory that's on that file, I can pull it in and take a piece that's in memory and push it out to the swap file, hence the name swap. In research computing, we try not to swap because it's very, very latency intensive. So it will slow your programs down tremendously. So in a lot of HPC systems, you will actually see where the swap file is of 0 size because usually high performance computing folks do not want to swap. And if they have to swap, then there's a problem with their program and they need to fix the problem rather than treat the symptom of increasing their RAM by a swap file. So coming back to the lower bottom back down here again, I mentioned that CPU, percent CPU is an important number. If your program is running efficiently, this thing should be at 100. It can actually go above 100%. Let's see. I don't actually see the number of cores here. But in a machine that has 16 cores, which I believe is what we have here, you could actually go up to 1,600%, and you would be using all the cores in the system. And there's ways to make your programs do this. That's called threading or using an OpenMP protocol. Memory, you will never go above 100% memory. Time is what it is. So this program here, well, the one that was just there had been running for 23 hours. So this is a monitor that runs on the system. Whenever the system is rebooted, it'll restart. As your program runs, hopefully that number is increasing. If your program is waiting on I/O and that number is not increasing, that might be a sign that you're waiting on I/O that's not occurring. A couple other this is the time of day. Looks correct. This system has only been up for a limited while. We have 30 users on the system. I'll use a command here in a minute to show you how we can look at who's on the system. And this load average is another number that's very important, and it's related to this percent CPU. So if we have 16 cores, the load average, if the system is fully loaded, would be 16 because we have 16 cores. In other words, it would be 1 for every core. Now this number can go above the number of cores as well. This load number, and it goes way back to the Unix era, and there's debates about what it really means. But essentially what it means is that any process that is computable. So let's say I have, just as an example, round numbers, I have 20 processes that are all ready to compute, but I've only got 16 cores. I could still have a reading of 20 instead of 16 because these processes are computable. One way to have a process that's computable but not really waiting on CPU is waiting on I/O. So if you submit a read to a file and you're waiting on that data to come from the disk or from the terminal, you actually have a load of one because you have a process that's computable. So if you're getting confused, don't feel bad. Like I said, there are computer scientists that sit around and debate what this means. But if you have a load that's very close to what you think it should be, like I'm just running a serial program, it should be one, then that's good. If you expect it to be one and it's climbing 3, 4, 5, then you would use maybe a program like top to see if somebody else running on this system, or look to see if maybe you are in like an I/O await state or something like that. So I think that's the most of top. So again, top is the top users. If I do question mark, this is like the help command. Or top can put out lots of different statistics beyond what's the we were looking at load average, I believe. So if I do a T, that'll show me tasks per CPU. That's looking at the cores, as I stated earlier. Mem is an important one that will look at how much memory processes are using. So I'm going to type Q or escape to get out. So Q. So I'm back to where I was running. So if I type T, I see a different view. And if I do L, again, just a different view, and then M for memory. This is a useful one. It gives you this little bar chart here, like that's for the number of CPUs that are being used. This is how much memory is being used. This will be important when you start running your bigger programs. And I've explained swap. Hopefully this never gets above 0. So, excuse me. I forget a drink here. Okay, so I've talked a great deal about processes. These are just applications or programs that are running on the cluster. I've showed you some of the parameters, essentially how many cores are you using, what's the load it's producing, what's its percentage of CPU and memory and things like that. I had mentioned, let's see who's on the system. So I have the W command. There's W and who. They produce a little bit different information. I don't know if this works. Can I scroll backwards? Yes. Look at this. So with the W command, usually the first thing I do when I log on is I do a W. A couple of things that shows me a couple of things, like how busy is the system? How many people are on it? I look at, and I see 30 users here. Now this is a login node to the cluster. So I do sort of expect a lot of users to be on here. If I'm out on a compute node, which we really won't get into today, but there should only be one user, that would be me. We do not, the idea in an HPC compute environment is that you have exclusive access to your resources and you don't share. Now that doesn't mean that there can't be another program running on your compute node, but the scheduler and the resource manager you've asked for a certain amount of resources and those resources are exclusively available to you. So anyways, again, load. I should mention that there's 3 numbers. I'm surprised somebody hasn't asked why is there 3 numbers. And so this is the 5, 10, and 15 minutes load averages. So for the past minute, the load's been at 0.22. Over the past 5 minutes, it's been about half of a core. So that just means that in the past 5 minutes, we've done more work on average than we have in the last minute. And then again, for 15 minutes, we were doing a little bit more work in the past than we are doing now. So again, W shows me who's on the system, gives me some statistics like when did they log in, how long have they been idle. Like this first individual here has been idle for 2 hours and 10 minutes. Turner GG, that's me. I have been idle for 5 seconds. And it shows the command that I was using. So again, if you have any, your man on who, if you have questions on it, who is showed, who's logged in, you can use actually we're using the more command. I've mentioned more and less earlier. So this is the more command. I'm going to hit the space bar and I will go down one line. So I can see what the command line options are. It will tell me what those parameters are at the top. And at the bottom here, it'll have a see also. So these are other commands that are very similar to the command I was just looking up. So I'd actually talked about top, so we're familiar with that. Who is the one I'm going to show you next? So I'm going to type Q to get out of here. So here's the who command. Again, it's just showing essentially the same. It's showing me the same information in the sense of who is logged into the system, but it's giving me a little bit different information, as in when did they log in and where did they come from. Whereas the who command is more process oriented. Looking at my notes here, there's PS-EF. This is the one I use mostly. I'm just going to show you a couple of different parameters. More. Again, okay. Here I'm using that pipe. I'm piping the output, standard output from this command into the more command. So, and notice that it did like the man page. It gave me one page. And if you resize your screen, it will give you more or less information. So I'm just seeing the top of this. If I do a Q, PS, UX. This is just another popular way of doing the PS command. I don't use this very much. Notice that it's just giving out different information. Again, do man on PS to find out which of these parameters will give you the information you want. This one's sort of good because it gives you CPU and percentage memory used. Here's the virtual size of memory. This is resident memory. This is the state, like it's running. We would have to look at the man page to see what these all mean. Start, what was the start time for this command? And notice that I started this at 11 o'clock, and that's just where we are. How much time has this command used, and what was the command? So this is just this UX is a popular way of looking at processes. And I also wanted to, no, I guess that's it. While I'm sort of in this state about showing the example of piping into more, so more does one page at a time. This is notice that when I hit return, maybe you can hear me hit if I hit return, I go one line at a time. If I hit the space bar, I go one page. Q. So programmers being programmers, if more did something, less does something similar. What's nice about less, and this will be the one you probably want to use, is that I can still do the space bar to move down one at a time, but I can also use my up arrows and my down arrows to move up and down and look at things. So you'll notice, just to comment on some of these processes on what did you see on the right side, these are system processes. It's not till notice that root owns all of them. If I get farther down, like Apache, there's our web server. I'm looking for something that's actually using a little bit of time. Doesn't look like much is going on. Well, the system hasn't been up for a long time either. Okay, I'm babbling. That's another important command, uptime. How long have I been up? So we've been up, it looks like about 7 hours. Looks like we've lost one user. Again, sort of, I'm just thinking out loud as I'm going along. Notice how our load here in the past 5 minutes was 2. So somebody was doing something on the program more than a minute ago, but less than 5 minutes ago. That increased that too. Are there any comments, any questions? Next, I want to talk about the environment. I have been talking about processes, and the environment. You'll see each one of these bash shells. I briefly described what a shell is, and that's the command line interpreter. When you type in a command, it goes out there and looks for a file with that name that you've typed in. As an example, let's do ls. This might be a bad one. So if I do ls, that's a listing of the files in my directory. I like to add the parameters APL. The P is habit. Most people will just use the AL. And also, if you just wondered what I did there, was I used my up arrow. So that was the last command I executed. I hit the up arrow a second time, and I'm just going back through history. Okay. There is a history command if you're interested. So I can pipe that into more. So here's all the commands I've been typing in for a long, long time. So this will actually, you can set the history, but how many lines you want to keep. It's probably 1,000 on my account, maybe 5,000. So these were commands I actually did for the last tutorial. Another important command, which is not on the cheat sheet I gave you, is clear. If I want to get rid of this distracting text on my window, I type clear, and it's all gone. So back to the ls APL. This is a rather busy home directory. PWD. My present working directory, PWD, is home. So this is essentially my home account. A synonym for the home directory is this tilde. You'll see me using it in this tutorial, or you will see other people using it. So let's say I move to a different directory, I CD, I'm going to change the directory. There's a directory out there called temp. There's all kinds of stuff in here. So if I want to CD back to my home directory, I can type just CD, and I'm back to my home directory. Notice that I have set up my prompt. Here I have my username, what's the name of the system I'm on, and what's the directory I'm in. So when I was in the temp directory, it said temp, and then when I went home, I have tilde. So again, just as an example, I should have, no, I deleted it. Let's see. Let me mention some of these files in your home directory. Remember when I did the bash or the history command? All it was doing was typing the contents, or actually catting the contents of this file, the bash history file. If I do a word count on there's 1,000 lines in there, so that tells me how long that file is. Something I don't know if I've been doing this, but I should. So a very important concept on Linux, something that you get with the bash shell that you don't get with the standard shell. Like when I did the bash or the word count .bash _h, I hit the tab key. So what that does is it goes out there and looks for a file that starts with what I had and will finish the rest of it. So scrolling back, I have several file names that start with .bash _something. So if I just type in bash and I hit tab twice in a row, I don't know if you heard that. The first time I did it, the bell rang. I got a little beep that's saying, well, I need more information. When I hit the tab key a second time, it gives me a list of all of the files that might possibly satisfy the tab completion. So in this case, I just wanted _h. I hit tab again, and it finishes it out. I execute the command. So I've explained the bash history. We have two files here, the bash profile and the bash RC. The bash profile, this script runs when I first log in. It runs only one time. So when I logged in via SSH, it creates a process, a bash process. That will be the parent of all subsequent child processes. So that bash shell runs this bash profile. To take a look at it, cat.bash _p tab. Okay, there's not much in here. And I should have mentioned this earlier. Scripts are a special type of file that are executed. So you put various different commands in these scripts. Then when you execute the script, it runs those commands. So these are things that I want done when I first log in. So if there's a bash RC file in my home directory, well, they're saying if this left square bracket is actually, that's a command called test. So test, is there a file located in my home directory named bash RC? If there is, then execute it. So this period means is equivalent to a command called source. Just as this left square bracket is equivalent to test, this period is equal to the command called source, S-O-U-R-C-E. It says source this command, or this script, I'm sorry. So if we look up here, there is a .bash RC. Okay, so I'm going to go into path here in a minute. I actually started off talking about environment variables, and this path is an environment variable. So what I'm doing here is that I'm adding, I should explain, this $home is equivalent to this tilde. Okay, so if you look in my home directory, and is there a directory called local.local/bin, add any of the commands in that folder to my path, and if there's a directory home/bin, then add those commands to my path. I'm going to look in my home/bin directory. So this is equivalent to this. So if I look in that directory, these are little scripts that I have written down through the years, and I find these very useful. So this is a place to put these little things that I need, like calculate the average and standard deviation of a column of numbers. this little script here will calculate or create a histogram, an ASCII histogram. My IP will get the IP of the host I'm running on. Random number will just randomly generate a random number for me between 0 and whatever parameter I put in it. Sum.pl, that just adds up all of the numbers in a list of numbers. So, you know, the idea of the script, well, this is a command I do over and over and over again, or a group of commands. I can put those group of commands in this file, and it will make life easier for me. So, now looking at, okay, I was talking about the bash profile. I want to look at the bash RC. The difference between the bash RC and the bash profile is that the profile file is executed one time. For every subshell, the bash RC is executed. So at this point, there's not very much difference in them. When you start doing more sophisticated things, there might be things you want in the bash profile that execute when you log in interactively, or the bash RC when you're creating a child process. You want those to be defined there, and you would put them here. So I will explain the etc. directory here in a bit. I should mention I will mention UMask in a little bit. This has to do with file permissions. Modules, I will also mention modules here a little bit. So again, that explains these login scripts. There's also a .bash logout script. A lot of times people will put a clear command in there so that when they log out, this command gets executed and it will clear your screen. This is handy for privacy and security reasons. So I have other directories here. We took a look in the bin one. I have a directory where I keep all my benchmarks. I have a directory where I build things. I have a directory dealing with containers. .forward, this is a way of forwarding email. If you get into running the slurm commands, when you run batch jobs, you may want the system to send you emails, and .forward is a way of sending those emails to the email address that you want. And that's really all of that is of interest there. Looking at my notes here. Okay. I'm going to do a little cutting and pasting here. I've used cat before. That's a concatenation command. So it's going to concatenate anything coming into standard input to standard output. I have mentioned pipes. I've used the vertical pipe, which pipes the output from one program into another running program. This actually sends the standard output to a text file. So it's, instead of sending it to a running program, it's going to send it to a file. These are the notes that are in the slide. All I'm doing. So I want to mention the file system. We're setting in home. I've described the home directory pretty well. Notice that we always start with a slash. That's called the root directory. So as I showed before, my current working directory is home and my username, Turner GG, my 6+2. So home / Turner GG is where I'm setting. And then before we had these directories, these files that have this slash at the end, those are directories for organizing my work. So the root directory is always called slash. Off of slash, there are various different directories. There's var for various different reasons. There's var log, var run, var could be lib. You probably won't be using much in there. I mentioned slash temp. This is a place where anybody can write files. Running programs will often write to slash temp. Files written there are temporary and they can be deleted at any time. Slash opt is rather important in a research computing environment. This is where programs are. So you'll find the modules file when we install software. It's probably being installed in slash opt. Slash user, there's many different slash users, as I mentioned with slash bin, or I'm sorry, with slash var. User bin is where a lot of the system commands are. So I've been using commands like ls. I mentioned that the left square bracket was equivalent to a command called test, T-E-S-T. So those programs are listed in user bin. You might try doing an ls slash user bin and take a look at what's there. There's going to be a lot of stuff. If you can't remember a command, it's probably in user bin. The man pages, I mentioned man before, so those are stored in user man. If you do an ls on user man, you will see that there are numbers like 1, 2, 3, 4, 5. The man pages that you're most interested in are coming out of the directory 1. Commands that the sysadmin would be using would be in directory 5. There's various different meanings for the different numbers. Once you get into programming, user lib will be important. There's also a user include. So the user include has header files that have information about libraries, and the libraries will then be in user lib. And I'll mention user local. We don't use it much on research HPC systems, but if you have a Linux laptop or a desktop and you're working on a server in your lab or something, a lot of times software gets installed in user local bin. There's also a user local man, user local lib. So all of these users that we had above, there's going to be a user local bin, man, lib, whatever. So just as I'm going to count up, or I'm sorry, not man, bin. How many programs are actually in user bin? I've added the -L to the WC command. That's just to count how many lines. -L. I'm using my arrow keys to go back and go forward there. So there's 1,811 commands in that directory. Another command is where test. Oh, where is test. So this is that command I was talking about that's equivalent to the left square bracket that's used with if statements, or there's also while statements and other ones. I think user bin slash. That work? Yes. So there's the where is source? I mentioned source. I don't know if this will resolve. Nope. Never mind. Ignore the man behind the curtain. Okay. I've talked about pipes, files, tab completion, more or less head, tail, which. Something very similar to where is which. So where is the ls command? Which is very similar. Oh, aliases. Yeah. Yeah, I got to talk about aliases. Notice that when I do the ls command, I have colors here. Okay. Actually, I'm going to create the world's simplest C program here. I mentioned this in the slide deck. So that is the world's smallest C program. All it does is load, run, and exit. I can compile it with this command. C. If you're ever running, when you get into programming, there are warnings and there are errors. Errors mean that your program did not compile. Warning means something happened that may or may not be what you think is happening. If you look at the text of the message, it's just saying that this function main defaults to int. Today, you would actually, I should have put an int there, but then it wouldn't be the world's smallest program. So anyways, when I compiled that program, it created this a.out file. So notice that it's a different color than the others. This green means that it's an executable file. I mentioned earlier about permissions. So that's what we see over here in this first column. Since this is an executable program, this is listed as in green. Now, with my vision, I find these colors distracting. So somebody somewhere thought it would be helpful to create an alias where ls is equivalent to this. So it means create this color when I do the ls command. And I don't like that. So I can unalias ls. Now when I do ls, everything is black. So some people like it, some people don't. So it's up to your individual. But anyways, how I started down this path was I did which ls. So now it shows me the path to ls. Before, it showed me what the alias was. Which ls. So it says, well, this is actually an alias to this command, which is then this was the command. This was the information I was looking for. So anyways, the point being, which ls and where is ls are very similar, except where is also includes this, where the man page is. Looking at my notes. Oh, I was going to talk about the permissions. This is very important for security and privacy reasons. So I had mentioned before that if over here in the name of the file, when I do ls, if there's a slash at the end, that's a directory. That's equivalent to this D here in the first column. There can be other characters there, but directories and the slash means that it's just a file. So what you will see now are 3 sets of RWX, and the character may or may not be there. You will notice the first 3 is RWX. These are the permissions that the owner has. The next 3 are the permissions that the group has. I'll explain group here in a moment. And then the third triplet is the permissions that the world has. So R is read, W is write, and X is execute. So let's actually look at this t.c file that I created. So just looking at this, anybody in the world could look at this t.c. There's one other caveat I'll get to in a moment. The group permissions, that's actually equivalent to what this second column is here. So This is my username. This is the group I'm in. We come up here. Well, it doesn't show. So anybody that was in the Turner G group could read this. And then me as the owner, I can actually read or write it. One other important thing to know about the W is that you need write permissions to delete a file. Another important thing to know is that this directory, if it's a directory, you need execute privilege to see what's in it. And I'm going to go up here. Now, if you remember, I said earlier that period is my current working directory, and I'm setting in my home directory. So the rest of the world cannot see into my home directory because the world, the last triplet, does not have execute permission. Now, I have not mentioned dot dot before, but dot dot is the directory above you. So I'm setting in home slash Turner GG. So the directory above me is slash home. Now, if you look at slash home, anybody in the world can actually look and see what's in slash home. So that's an idea of all the users on the system. So I can see into slash home, but I'm not going to be able to see, unless they've changed their permission, I'm not going to be able to see into their home directory. Usually in an academic environment, we set that on purpose to be no world read. If you have a desktop server or personal laptop, that may not be the case. Again, just a comment about programmers and sysadmins. Programmers are on one end of the spectrum, and they want to make life easy and for everybody. So they have a tendency to make things secure. Security is not something they think a lot about. Sysadmin's job in the world is to make systems so secure that they're not usable. And then they tweak it so that to loosen up the security just a little bit so that it is usable. So for your home laptop, you may have a permissions like this where you can look in it and you can read files in that directory. But in an academic environment, for obvious reasons, privacy and security, we lock these down pretty secure. There are ways you can use a command called chmod, CHMOD. You can change these permissions on these directories. Let's see. Do I have a temp? Created a directory, make directory temp. So what I do. There's my temp directory I just created. Temp. Oh, I don't do it this way. Let's see. If I want to remove world read privilege from temp, okay. Actually, if you're an old programmer or an old sysadmin like me, you use the numbers. But now when you notice that I have removed the read execute permissions, so 7 is everything read, write, execute. 0 is none of them. And the reason why I didn't do just didn't say why not? Why don't you just show me ls temp? It actually shows me what's in temp. Cannot X. Oh, forgot to dash it. So it shows me what's in temp. It doesn't show me temp. What I was looking for before. So I've been babbling for an hour and a half. Are there really no questions? I'm getting close to the end of my prepared statements. I can use this opportunity to look at open on demand. So hearing no questions? What's my, let's see.
We do have some questions in the chat box now.
Okay, yeah.
What's your favorite obscure but underappreciated Unix command?
Oh, log out. Oh wow, obscure. Yeah. It's not obscure, but it's probably one of the more powerful commands that is the awk command. And you know, there are entire books written on awk, but and I don't even have the full. So I'm talking about AWK. Oops, AWK. So if I do an ls-apl, you'll notice I have columns of data, like 1, 2, 3, 4, 5. So if I want to print the 5th column, oh yeah, print $5. Now this is going to go horribly wrong. But notice that it just printed the 5th column. There's so that's probably, it's not necessarily obscure because anybody that's using the Unix environment will use awk all the time. But that command is so powerful. There are ways to do the test within the awk. I mean, I just use it more or less for the give me this column of data.
Yeah, they
the command line. Yeah.
Another question, George, is how do you move files back and forth from Windows to Linux?
Okay. Back in the slides, I mentioned PuTTY. So PuTTY is an application that you can download from putty.org, I believe. But it has a mechanisms for copying or for doing the copying the files from your local Windows box to the foreign system. If you were on a Mac or a Linux, you would use a command called scp. Again, you know, scp. More details than you ever wanted to know. So CP is the copy command. SCP is the secure copy command. The two commands are very similar. So if I wanted to copy a file, actually, let's see. Let me log out. Here's an obscure command. I'm going to hit Control D. That's equivalent to exit. So now I'm actually setting on my home directory. If I wanted to copy a file, say cat d.txt, okay. So in PuTTY, it's very much a Windows-oriented GUI, graphical user interface environment. So within PuTTY, there are means of pointing and clicking on a file and say, I want to copy this file or this directory to the foreign host. And you have to identify where that host is and what that directory is in another GUI window. So you'll have to check the PuTTY documentation on exactly how to do it. But it's very pointy clicky. You can figure it out. If you were not, and essentially what's going on underneath the cover is it's doing a copy from this file to oops, I'm not. So what's happening underneath the pointy clicky windows is that I'm going to do a secure copy of some input file to the arc UCEDU : I can't get it over for you. So that colon is very important, and I guarantee you, when you start working on a Linux or a Mac, and you're trying to copy something from here to there, or even from say maybe you want to copy it from the ARC to a computer at OSC or something, SCP is what you'll be using. If you don't put that colon in there, it's that colon that says this is a host name. It's not the name of a new file. If you don't put that colon in there, it will just copy that file into the name you've given it there in your current working directory. And then you have to figure out how you're going to rename a file that's got an @ sign in it. But anyways, so again, I'm copying a file from here to that foreign destination. It's going to come up and ask me, this is equivalent to asking what my UC password is. It's asking me for my private key password, which is, so I typed in my password for my key, and so it copied it over there. So what's happening is this is a secure copy command. So what it does is encrypt the file, encrypt the data as it sends it across the wire. And then on the other end, it actually uses that public key I talked about to unencrypt the data and then write it to a file. If I come back over here, I probably used a bad file name. I'll move it up. So at 11:38, I created the file t.txt. That was the one that I copied over from my laptop. Okay, so that's what's happening underneath the, if you're, again, just recapping on Windows, get putty, and underneath it's doing this command. And actually, while I'm here, I'm just using the up arrow. Putty, the way it's connecting from your Windows laptop to the ARC is executing this command, SSH username @ ARC. So it's essentially the same thing. What's my password? So now I've logged in. So that's what putty's doing when you log into the research computing. SCP is the way to copy files. Was that? You're welcome. Oh yeah, somebody mentioned, Kevin mentioned CyberDuck. I've not used CyberDuck. It is worth your time to play with it. I've talked about a hierarchical file system where you have root, the / partition, and then you have folders within folders within folders. That's you will often hear that called a POSIX file system. Today, new type of computing is cloud computing, where you have objects, or you may hear about S3 storage at Amazon. Object store is essentially just a blob of bits. Essentially, the equivalence with a file would be you have the starting address of a file and you have a size of a file. So an object has a starting address and it has a length. And what those bits are only make sense to you, the person that is interpreting the object. Now that object could be a web page, which if you've seen me use the cat command. If you cat this object that's a web page, then you'll see all of the commands that make up the web page. This is a very common way of actually creating a lot of these web pages out there. They're just objects somewhere in the cloud. That object could also be a data file. that say you have a research instrument that's creating data and it's putting it in this object that's stored as an S3 object. So the point I'm building up to is that CyberDuck knows how to deal with these objects. So it's worth learning how. It's not something you will be using on the Arc, but the time you spend learning how to use CyberDuck will come in handy somewhere down the road. See, Amy's put in a, wow, there's been a lot here. I just did open up the chat. Was there any other comments or questions that obscure 40 core? Okay. As I said, that's the end of my prepared statements, but I do want to show, I'm going to continue to babble till my allotted time. I'm like a congressman, I'm not going to return it. On demand is a way of getting some sense of graphical access to the ARC clusters. And more high performance computing clusters are starting up on open on demand. So this is another one that's the time you invest in learning this is not wasted. I don't know if I can open up 2 sessions or not. I'm using the Safari web browser here. I'm a Mac user, so I just pointed my web browser at arc.uc.edu. Okay, so I hit return. I'm hoping it'll show me that I have to log in. Oh, since I'd already logged in, it's not asking me for my username and password. But that would be just your 6+2 if you're using your UC account or the training account that was created for this class. So if you just type in your username and password, you'll end up with a web page that looks like this. I'm going to close this one here. Going back. The main work is actually up here at this top. No, that doesn't work. This area that I'm highlighting in blue, that's where your commands are. There's a logout button that tells me who I'm logged in over here on the right side. There's help for on demand, so those are places you will want to play with. If I look at files in my home directory, notice that it has created another window. This was my original one. So here's a list of the files in my home directory.
Can you make that screen a little bigger?
The fonts?
Even just the window itself.
Like that? Or
yeah, I think at least people have a better sense there. Thank you.
This is what I think you mean. Like that?
Both, yes, great, thanks.
Okay, oh yeah, because I'm sharing the whole screen, which I have a nice big 30-inch monitor, so that's why you were seeing a really small. But here on the left side, you're seeing the hierarchy I was talking about before, my home directory. These are the directories that I have within my home directory. I just made this temp directory a little while ago. I can point and click on it. No, there's nothing in it. Going back to my home directory. Here's a download key, so I bet you can upload and download. I have to admit, I don't use this very often. Never is not the right word, but almost never. You know, I learned to program on cards, so I do things the old way. It's just more muscle memory than anything. That's when I clicked on the download. That's just my Mac. I've got security pretty tight on it, and so it's just asking whether I want to do that. I don't know. Benchmarks. These are some benchmarks I copy to all systems I get onto just to test different things. bin, I already showed you. These are just some handy little scripts I use. I don't know if I can actually, I don't know what happened. Edit. Oh, I can edit. Remember I was talking about VI before? Apparently I can edit this file in a GUI environment. So this is a Perl program. Again, I'm showing my age. Everybody uses Python anymore. But I just take an argument in and I pass that to the random number generator, and it'll print out a number between 0 and that number I pass in. I can click out of it. Other thing, oops, no, not that one. Go back. Remember what I said with a live demo. Watch this. I don't have any jobs running. If I click on active jobs, this will probably give me a list of everything that's running in the cluster. Now, it's only showing me my jobs. I guess I can, your jobs, all jobs. So there's a list of all of the jobs that are currently running out there. This probably not of much interest at this point in time. Interactive apps is pretty cool. Most people are used to using a GUI interface for either their Windows or Macs. I'm going to create a desktop on one of the compute nodes. My session was completed. If I click on this number. So this is, I'm actually setting on one of the compute nodes back on the back side. This is not the login node where we were running before. So I can run programs out here on this compute node. I know some people use this mechanism for starting up like MATLAB or ANSYS. Again, life is an experimental science. This is my primary philosophy. Life is an experimental science. You try things and see what happens. So play with this stuff. You're going to learn more by playing than you will just listening to me. I'm going to go back to home. Oh, wow. Jobs, we looked at that. Job Composer will be an important one when you get ready to, if you're not comfortable with working with batch scripts and things, this will be important for helping you create the job scripts that you will submit to the Slurm scheduler and will run on the backside. We'll take a default. I'm just pointing and clicking here. Job names. Can I edit this? Nope. No, here's your hello world thing. I could do things like, apparently, I can change the name, the folder contents. I'm sure I can edit this here. Open editor. Job headers here. Job headers are things like, so here I'm passing a Slurm command saying I want 2 nodes and I want to run 4 tasks. In the slide deck, there's some of this is explained. So you can play around with some of the examples there. I'm not sure why it's taking so long to come back. Hold that one. Clusters. I have not played with the Jupyter notebooks. I know that Jupyter notebooks are very popular. It's a way of, if you're unfamiliar with what Jupyter notebooks are, it's a way of, the way I've used them and seen other people use them is that they're great for teaching, in the sense that you can have like text that explains what you want the student to do. Then they get to a window where they type in commands and things happen on the computer. Output gets written. You can apply, filters which can plot the data, things like that. I assume if it's going to be something destructive, give it a big red. Well, it looks like I actually have 2 open desktops. So anyways, this is a simple way to get some GUI experience and not have to learn all of those text commands. Again, it was very simple. I just pointed my web browser at arc.uc.edu and started pointing and clicking. With that, I'm going to end. Are there any questions? And if there are questions, once you start playing with this, once you leave, remember arc_info@uc.edu. They're there waiting to help you. This is a resource that we're standing up at UC, and we really want to see people take advantage of it. So.
Thank you, George. Yeah, I posted some links, our email in the chat box. Don't hesitate to get in touch with us. We know everyone's at a different level. So we are a small but capable team. So reach out because we want to help you. Kevin does have one last. A lot of stuff has been happening with ARC since the last time I went to one of the workshops. Are you all excited about any new equipment or capabilities that you've recently added or will be adding in 2021? Yes. So with Dr. Prashant Kare, we received MRI grant from the NSF this in 2020. So we are purchasing a big storage unit. We're buying, yes, so we are adding on. There will be big changes. We've also moved to the Office of Research. We're part of the Research Technologies team there now. So we have lots of, we're growing in terms of hardware, software, and personnel. So I'll make sure we'll have a newsletter that we'll be sharing, and we'll make sure everyone sees how we're growing. Next Friday, we also have a Jetstream workshop, which I don't know, George has done a lot of talking, but he is part of that team. His colleague will be facilitating it. It's cloud computing. It's NSF funded. It's free. So I don't know, George, do you want to just speak to Jetstream for the last minute? And then I will let everyone go. This, like I said, this is recorded. I will post it. I will share it. And then you can reference it at your convenience. So thank you all for attending today. I'll let George just say one more minute about Jetstream. And also these accounts are just set up for this workshop. So if you want to create an account on ARC, go to the website and submit your request, and we'll get you set up.
Yeah, thank you, Amy. Yeah, Jetstream is, there's this entity called Exceed, and they used to be just in building these supercomputing centers. And 5 years ago, the National Science Foundation, well, before that, they did a survey, and they found that only 3% of the researchers that the NSF supports actually knew how to program these giant supercomputings. So that meant 97% of the researchers in the United States weren't actually gaining access to the money or benefiting from the money that the National Science Foundation was investing. So the Jetstream program is for some, it has these VM or these virtual machines that are a little bit more than a laptop, but not the big supercomputing type stuff. So one of the great slides we have, and they'll probably show it next week, is the a picture of a laptop strapped into somebody's front seat of the car, and they can't close the lid because they got a calculation running, and if we close the lid, it'll just crash and die, and horrible things happen. So another nice thing, well, these VMs that you create on Jetstream are Linux VMs. We've been running on real hardware today, but these are Linux virtual machines. So you can create them, you can destroy them, you can copy them. It's like, well, everything in the cloud is a software-defined fill in the blank. So these are software-defined servers, Linux servers. Now, I mentioned at the very start about Docker and Singularity. Singularity is Docker that you would use on a HPC system. To create these Docker files, you need to have root. Root means you have all the privileges on the system. And on an HPC system like the Arc, you're never going to get root. You're never going to get privileges. But on Jetstream, you can have root access to these VMs. And you need root access to create these these Docker Docker containers. So if you want to get into packaging your software up using Docker, Jetstream is a very good place to go. One final comment on Jetstream. It was originally envisioned to be a place where domain scientists created these virtual machines, and then other colleagues within their domain can go there to Jetstream. There's a library. You double click on something, like I'm an astronomer. I want to look for something that has IRAF installed on it. I double click on it, and within seconds I have a virtual machine, a desktop with all my astronomy software installed on it. So that was the original idea. You can go to jetstream-cloud.org. You don't need an account to log in. You can look at the library of what's already installed there. I hope I have whetted your appetite for next week's. With that, I return the balance of my time.
Yes, indeed. Okay, thank you, everyone. If there are no last-minute outstanding questions, I'm going to conclude. And we'll be in touch with this recording and additional information for you. So thank you today.
Be safe, be well.
Have a good weekend.